Similar figures are figures that maintain the exact same shape, but not necessarily the same size. So in order to maintain the same shape, we call these figures proportional. An example of proportional relationships is if you're going to make pancakes and you follow a recipe that makes 12 pancakes, but you only want to make 8 pancakes. So you want to make sure the ratio to flour, to sugar, to baking powder, to butter, milk, to eggs, to tablespoons, you want to make sure that that ratio all stays the same, because you want to make sure, otherwise it'll change the taste of your pancakes. And so if we want 8 pancakes out of 12 pancakes, then, and we reduce this fraction, we can divide it by 4. That's 2/3 of every ingredient over here. So that means I would add 2/3 a cup of flour, pretty easy to do. 2/3 of a tablespoon of sugar, a little bit more complicated. 2/3 of a teaspoon, more complicated. 2/3 of a cup of buttermilk, that's fine. I don't know how you're going to do 2/3 of an egg, and then 2/3 of 3 tablespoons of melted butter would just be 2 tablespoons. So that's an example of everyday life, how we use when we would use proportions. This is section 7.1 in your textbook, ratios and proportions. How can we compare fractions? A ratio is just anything that compares two values. There's 3 ways that our book uses ratios. One of them is using the colon. One of them is using the word to. And one is using a fraction, a to b. I'd say this is probably the most common, but this is also used quite a bit. Find the ratio of freshmen to non-freshmen in this classroom. So say we have 14 freshmen and we have 16 non-freshmen. Then the ratio of freshmen to non-freshmen would be 14 to 16. We could reduce this to 7 to 8. For every 7 freshmen, we have 8 non-freshmen. Another example of a common ratio that we've already looked at is slope. Rise over run. We're looking at the ratio of the rise to the run. And we had our formula y2 minus y1 over x2 minus x1. And so this would be x1, y1, x2, y2, and we get 3 minus 1 over 3 minus negative 3, which is 2 over 6. And we want to always reduce, so the ratio to the rise to the run is 1 to 3. We go up 1 and over 3. We can do this again. I find it helpful to stack your points, write one over the other. And then you can just look at this, subtract your y's, negative 4 minus 4, and 1 minus 3. We get negative 8 over negative 2, which reduces to positive 4 over 1. You can try the last one. Now's a good time to pause the video, try this one on your own, and then check your work. Got 3 over negative 2. And notice I'm always leaving my answer as a fraction, not writing it as a decimal, not negative 1.5, because I want to leave it as a ratio, a fraction. Here's an interesting example. The ratio of the side lengths to a triangle is 2 to 4 to 5, and the perimeter is 55 centimeters. What is the length of the shortest side? So if we think about a triangle, it doesn't necessarily mean that the sides are 2, 4, and 5, because 2 plus 4 is 6, 6 plus 5 is 11. That's not 55. It means that it's been reduced by some factor in every side. So we can think of it as 2x plus 4x plus 5x equals 55. And so we said we had 11 x's, and that means x, our multiplier, is 5. So the shortest side would be this side with 2x, and the shortest side length would be 2 times 5, which is 10 centimeters. It works the same way with angle measures. 7 to 13 to 16, but we know that all the angles in a triangle add up to 180, and 7 plus 13 plus 16 doesn't add up to 180. So it's been multiplied by some common factor. 7x plus 13x plus 16x is 36x. And I'm going to set that equal to 180. Then I'm going to find x by dividing both sides of my equation by 36. I get x equals 5. The question asked for the largest angle measure. That would be the 13x. And 13 times 5 is 65 degrees. A proportion is an equation that shows two ratios are equal. In a proportion, the cross products are equal. Cross product means when you multiply the diagonals. So I have AD equals BC. This is true anytime we have a proportion. So for example, you can see that we have two similar Nike shoes, and I can set a proportion 8 over 12, 8 matches up with 12, is equal to 4 over x. The ratio of the length of the shoe should be equal or proportional to the ratio of the heights of the shoes. And I set this equal. If these two fractions are equal, then their cross products are equal. So 12 times 4 must be equal to 8 times x. 12 times 4 is 48, so 48 equals 8x. Find x by dividing by 8 on both sides. X must be 6. So the height of the bigger shoe is 6 inches. Write a proportion 4 different ways using the numbers 5, 10, and 1 and 2. Well, 5 over 10 is equivalent to 1 over 2. 5/10 and 1/2 is a proportion. I could write this the other way. 10 over 5 is equal to 2 over 1. That's true. Another way I could write this is 2 over 10 is equal to 1 over 5. Notice that the cross product here would be 1 times 10 equals 5 times 2. 1 times 10 equals 5 times 2. And the fourth way to write this is the reciprocal, 10 over 2 is equal to 5 over 1. So it doesn't really matter what way you set up the proportion, because you can see here there are 4 correct ways to set it up. All of these are correct. In order to solve a proportion, we cross multiply. We set the cross products equal. 36t is equal to 9 times 28. So I'm going to do 9 times 28 on my phone, on my calculator. I get 252. And then I'm going to divide both sides by 36. I get t equals 7. Pause the video now and try the rest. Set your cross products equal. $15 times 32 is 480. And then divide both sides by 16. So x equals 30. 42y equals 24 times 7. $168 divided by 42 is 4. This last one's a little tricky. 3 times 8 is 24. But when I multiply 2a times 3a, I get 6a squared. Divide by 6. I get 4 equals a squared. And then to get rid of the a, I take the square root. What number can I square to get 4? I could get 2 or -2. So 2 possible answers for that one. I want to write the simplest ratio from B to C. What would my fraction have to be in order to multiply 5 times B? 5 would have to go in the denominator, and 20 would go in the numerator. So the ratio of B to C would be 20 to 5. Oops. And 20 divided by 5 is 4 to 1, if you were to reduce it. I have no idea what I just did. So same example, x to y. I don't know what I did to my iPad. Okay. So if I want x over y and it's 24x, then the 24 must be on the bottom, and the 9 on the top. And then I want to figure out, is there a way to reduce that? Well, I could divide the top and bottom by 3, and I get 3 over 8. Simplest form. A recipe calls for 4 cups of flour and 1.5 cups of sugar. Jade only has 3 cups of flour. How much sugar should she use? Well, she has 3 out of the 4 cups needed. How much sugar should she use if originally it calls for 1.5 cups of sugar? So basically we want 3/4 of 1.5. Well, we can set our cross products equal. 4x equals 3 times 1.5. Well, 2 times 1.5 would be 3, so this is going to be 4.5. Divided by 4. And I get 1.125 cups of sugar, or 1 1/8. Thanks for watching.